Okay, so so what we'll do here is we'll take a look at this question here. It says, what color will the indicator phenolphthalein be in a solution with a hydronium ion concentration of 2.58 times 10 to the negative 4? So in your textbook, you'll have a list of pH ranges where indicators are a certain color within this pH range, and then they change to a different color at another pH range. So phenolphthalein, if we look over here at phenolphthalein on this chart, it shows us that the turning point here, okay, is right around 8.5 to 9, okay? So in this range here, in this very narrow pH range, right about here, that's when it's going to start to turn color. It's going to be colorless on this when the pH is in this range. It's going to be pink or red when it's on this side, okay? So that's how you interpret these charts. And indicators are helpful when we're doing titrations or when you want to know what the pH is, a very narrow range of the pH at a certain point in an experiment or something like that, okay? And actually this works like if you have a hot tub or if you have a pool or something, you dip those little indicator strips, okay? It's a similar sort of thing. Like there's a bit of a gradient, but that indicator by the color will tell you sort of what the pH is and different other things. So how do we do this? Well, we have to go to pH. We have to find pH. Okay, that's very important. So what we do, we understand that pH is the negative logarithm of the hydronium ion concentration. So that's 2.58 times 10 to the negative 4. And we simply determine this pH. So we'll get our calculators out here and we will just plug that in. So negative logarithm of 2.58 and use your EXP button or whatever you have there for scientific notation to the negative 4. Okay. And we hit enter and we see that our pH is 3.6 or so. So pH is 3.6. And so what you do is you look over here, where's 3.6 right about here? So obviously the phenolphthalein over here, 3.6, we are in the colorless side. So what color will the phenolphthalein be if this is the case? Well, it'll be colorless. Okay? Colorless. That's your answer and there's your work. Okay, so if you have a question like this, find the pH, check the pH ranges. If we had a different indicator, so let's just take one quick peek here. 3.6, okay, so if I wanted to find out when my acid solution was exactly at 3.6 or pretty close to 3.6, check this out. According to this chart, 3.6, right, is right here. So guess what? If I used the indicator methyl orange, I would be able to tell when this thing turns from either red to yellow orange, then I would know at that point where it changes, I would know I'm pretty much at 3.6. So that's why using different indicators can give you a visual as to what the pH situation is in your solution. So yeah, so if you wanted to target a certain pH, you would pick the appropriate indicator. If I wanted to target, let's say, something like a pH of 7, I wanted to know exactly where we are evenly balanced here. A 7 looks like I'd use phenol red. And so when it goes from yellow and when it just starts turning red, you're right about 7. So this is where it would turn red. You might want to pick bromothymol blue too and see where the yellow turns to blue. That might be a good indicator there. It also helps if you have an acid solution and you're adding base. When do you stop? Well, you might want to use this one because as soon as it turns blue, you stop adding and then you know that you're right up to 7. Okay, and if you go a little bit over, you know that you're just, still at 7. If you have an a basic solution, what did I say? Acid adding base. Yeah, if you have basic and you're adding acid, you might want to use this one because when it starts to turn red, right about here, you can stop, and if you go over a little bit, you're still pretty close to 7. Okay, so that's a little, some info on indicators and their calculations.